Hey guys, this is Mrs. Schoenberg, and this is 13.5. It's our very last lesson of this 5 weeks course. And this is called Rationalizing Denominators. And basically, in this lesson, we are going to be rationalizing the denominator. Okay, the denominator is the bottom part of a fraction. And there's basically a rule that says you cannot have a radical sign or a radical expression in the denominator. So I'm going to show you some ways on how to rationalize the denominator. In other words, let's get the radical expression out of the denominator. So over here is the rules that you'll find in the Learn section. If it contains a square root or a cube root, you multiply both the numerator and the denominator by an expression to get rid of the radical expression. Okay? To rationalize a denominator containing a sum or difference involving square roots. Well, here's a new term here. It's called the conjugate of the denominator. We'll get to these in the second part of this lesson. These down here below this line, if you look at the denominator, you'll see that there's addition or subtraction going on. So if the denominator is in the form of a minus b, you'll multiply by a plus b. It's kind of like multiplying by the opposite, but they call it the conjugate. So let's just make sure we know what that means. So if the conjugate is 1 plus square root x, then we're going to multiply by the conjugate of 1 plus square root of x, which is simply 1 minus square root of x. And you notice, if you remember, the thing that's special about that is it's not only going to get rid of the middle terms, but it's also going to get rid of the radical expression. Kind of hard to explain until you see it, so let's just jump in. First of all, these up here, these do not have, this is not dealing with the conjugate yet. There's no addition or subtraction in the denominator here. So when you think about 5 over the square root of 3, what can you multiply to get rid of this radical expression? Most of the time, it's going to be times the square root of whatever's there already. But remember, what you do to the bottom, you have to keep everything in balance, and you have to do it to the top. Okay, so the final answer here is 5 square root 3. And remember, square root of 3 times the square root of 3 is poof, magic. It's just 3. But you can also think about it as the square root of 3 times the square root of 3 is the square root of 9. And the square root of 9 is 3. There's no simplifying that can be done in this one. So we're done. Again, the whole purpose of this lesson is we cannot have a radical sign in the denominator of a fraction, and so we're rationalizing that. So let's try this approach again. Let's multiply top and bottom times the square root of x. Now we have 4 square root of x over x. Done. Okay, I hope you have a lot of these that are easy. All right, let's think about this one. We have 7 square root 2. I'm simply going to multiply by the square root of 2. What I do to the bottom, I have to do to the top. So I have 3 square root 2. This becomes, let me write down the number and see if you can calculate how I got it. 14. How did this become 14? Square root of 2 times square root of 2 is 2. 7 times 2 is 14. Now, and I can't simplify this. If this had been 2 square root 2 over 14, the 2 and the 14 could have been simplified. But in this case, we're not going to simplify. You can look at this number on the outside is what I'm trying to say. The 3 and the 14, they are in simplest form. Okay, now looky what we're dealing with, a cube. This is when these get a little bit trickier. So you have to think in terms of cube root. So now we have to multiply by something to get this to a perfect cube, okay? So I am thinking, I hope you're thinking what I'm thinking. If I multiply times the cube root of 25, I'll show you what happens here. On the top, I have 3 cube root of 25. And on the bottom, I have the cube root of 5 times 25, right? And that equals, this equals the cube root of 125, okay? And that becomes my perfect cube of 5, okay? Again, I had a 5, and I had to think of, I knew that 125 was a perfect cube, right? So I had to ask myself, how do I get 5? What can I multiply by 5 to get to 125? And that number is 25, because 25 times 5 is 125. Then I could take the cube root of that, and that is 5. And I've gotten rid of the radical expression in the denominator. Whew. Okay, here's another one with a cube root. And not only do I have to take care of this 32, but I have y to the first power here as well. So if I looked at my perfect cubes, you know, you have 1 times 1 times 1 and 1. Then you have 8. Then you have 64. Ooh, 64. So if I could get this 32 into a 64, and then this y to the 1, if I could get that up to y to the third. So I'm going to multiply times the cube root of 2y squared. Multiply times the cube root of 2y squared. Okay, let's see what we get here. On the top, we have 7 cube root 2y squared. And on the bottom, I have the cube root of 64y cubed, which can all be simplified. Nothing can be simplified on the top. But the bottom, I can take the cube root of 64, which is 4. And I can take the cube root of y cubed, which is y. Okay, so that is my answer there. Moving on here, to rationalize the denominator containing sum or difference involving square roots. This is where we're going to multiply it by the conjugate. This is 4 minus, so we're going to do 4 plus square root 2, and what we do to the bottom, we have to do to the top. Then we're going to FOIL, but on the top, we're going to distribute. So I have 8 plus 2 square root 2 on the top. On the bottom, I have 4 times 4, which is 16, plus square root, plus 4 square root 2, minus 4 square root 2, minus and plus is minus. That just becomes 2. These terms cancel. I have 8 plus 2 square root 2 over 16 minus 2, which is 14, okay? This one right here, we're gonna multiply 6 minus square root 5, top and bottom. This was 6 plus, this is 6 minus. Okay, so what we have here is this becomes 186 minus 31 square root 5. On the bottom, I have 6 times 6, which is 36. My middle terms are going to cancel each other out. And my last two terms, because minus and minus, square root of 5 times negative square root of 5 is just minus 5. So you get a little bit quicker at these. But my final answer on this one is 186 minus 31 square root 5 divided by 31. All right. This one right here, I'm going to multiply top and bottom times square root of 7 plus square root 2. Square root 7 plus square root 2. And here's what I have on the top. Square root of 7 plus the square root of 2. On the bottom, the square root of 7 times the square root of 7 is 7. Plus 2 minus that, those will cancel. And then the last two terms, minus square root 2 times plus square root 2 is just minus 2. So I have square root of 7 plus the square root of 2 divided by 5. And that is my answer on that one. All right, so on and so forth. These aren't humongously different. I do want to show you one problem that stumps students. If you get something like this, cube root of 3 over 2. Just want to add this one in at the end. This one kind of stumps students. And I want you to think of it this way. We don't we don't care about the top as much as we care about the bottom. There is, how do we turn 2 into a perfect cube? If you're thinking about, hey, let's multiply times 4, because that'll get that up to an 8. Okay, so when we do that, we can't just simply multiply times 4. We have to, let's see, how do I want to set this up? I'm going to set it up this way first. Cubed root of 3 over the cubed root of 2. Then I'm going to multiply top and bottom times the cubed root of 4. Now what do we have? On the top, I have, this becomes the cubed root of 12, because 4 times 3. And on the bottom, this becomes the cubed root of 8. And then my final answer here is the cubed root of 12 over 2. Okay, so I hope that helps. If you have questions, please let me know, and I will post these in Canvas.